Hello everyone, my name is Varsha Tandur from Sri Venkateshwara College of Engineering. So today in this video, we will be learning about corrosion, its types, its control methods and prevention. Definition of corrosion. It can be defined as the destruction or deterioration or loss of metals or alloys by the surrounding environment through chemical or electrochemical reaction. Example is the rusting of iron where a reddish brown scale formation is seen on the iron objects. First, the iron ions is reacting with two molecules of hydroxide ions, which gives ferrous hydroxide. Further, the ferrous hydroxide is reacting with oxygen and two molecules of water in order to give a rusting complex, that is hydrated ferric oxide. Types of corrosion. We have two types of corrosion, that is differential metal corrosion and another one differential aeration corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as anode, undergoes oxidation and gets corroded. The other metal with higher electrode potential acts as cathode, which undergoes reduction and is protected from corrosion. The rate of corrosion depends mainly on the difference in electrode potential between two electrodes. Higher the difference, faster the rate of corrosion. So if you look into the example, we have iron in the anode and copper metal in the cathode. Since iron is having a negative electrode potential value, it acts as it undergoes corrosion easily, whereas the copper metal having a positive electrode potential, it becomes cathodic and remains unaffected. Differential aeration corrosion. When a metal is exposed to different concentrations of air or oxygen, part of the metal exposed to lower concentration of oxygen becomes anodic and undergoes corrosion. The other part of the metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. If we see in the example, an iron rod is immersed in a water vessel. The part of the iron rod which is immersed into the water is exposed to a lower concentration of oxygen, or you can say a dissolved oxygen. So that is why it becomes anodic and undergoes corrosion. Whereas the upper part of the iron rod, it is exposed to higher concentration of oxygen. So that is why it remains unaffected. Under aeration corrosion, we have waterline corrosion and pitting corrosion. It is observed in iron or steel tanks partially filled with water. A distinct brown line is formed just below the water line due to the deposition of rust. Pitting corrosion, it is observed when dust particles or oil drops deposited over the metal surface. The less aerated becomes anodic and undergoes corrosion and form pit, whereas the other part remains unaffected. For the corrosion control methods, we have galvanization, which is applicable only for the ferrous metals. So, what is galvanization? The process of coating zinc on the base metal surface by hot dipping is known as galvanization. The galvanization process is carried out as follows. At first, the metal surface is treated with an organic solvent in order to remove the impurities. Then it is treated with dilute H2SO4 in order to remove any rust particles or the other impurities. After that, it is air dried and washed with air. Then it is treated with a mixture, zinc chloride and ammonium chloride, which acts as a flux in order to prevent the oxidation of the coated metal. Then the metal is dipped in the molten zinc at 450 degrees Celsius. After the coat, the excess of zinc on the metal surface is removed by a pair of hot rollers, which removes excess of zinc and produces a thin coating. The galvanized materials are used in fencing wires, buckets, bolts, nuts, screws, etc. Cathodic protection is the technique of offering protection to a specimen against corrosion by providing electrons from an external source. There are two important methods of cathodic protection: sacrificial anode method, impressed current or voltage method. Sacrificial anode method. The sacrificial anode method involves the use of a metal which is anodic to the specimen. In this method, the metallic structure to be protected is connected to a more anodic metal using a metallic wire. More active metal gets corroded while the parent metallic structure is protected from the corrosion. Example, if you see a steel pipe which is to be protected from corrosion is placed at the cathode and the more anodic metal is placed at the anode. When the sacrificial anode gets exhausted, it is replaced with new ones. The commonly used sacrificial anodes are magnesium, aluminum, zinc, and their alloys. In impressed current method, the metal to be protected is connected to the negative terminal of the DC power supply. The positive terminal is connected to an inert electrode such as graphite. Under these conditions, the metal acts as cathode and hence does not undergo corrosion. The inert electrode acts as anode, but it does not undergo corrosion because it is inert in nature. The metal which is to be protected is connected to the negative terminal of the battery, and for the positive terminal of the battery, inert material is connected at the anode part. For advantages, requires low installation cost and minimum maintenance cost after installation. It is used for protecting water storage tanks and oil pipelines. Thank you for watching.